So we need to compute the first derivative of this function, right? So here, derivative of this function. So first, this is a sum and the difference. So the derivative of this will be the derivative of the each terms inside, right? So the first one, 2 over x derivative plus 3x squared. And remember, the derivative of a constant, we can take it out of the derivative things, right? And the next one, the constant 1 over 3, we can also take it out. Negative cotangent derivative plus derivative of e to the negative 2x. Okay, let's do it slowly. Now the first one. What is it? What is the derivative of 2 over x? Perfect. Negative 2 over x squared. Right? You apply the quotient rule. Okay. Good. So how about the second term?
6x.
Yes. Derivative of x squared will be 2x and 2 times 3, which give us? Very good. And the next one.
X squared. Negative x squared.
Very good. 1 over 3 times 3x squared, right? And 3 will cancel with 3. Very fast. Very good. And cotangent derivative. Cotangent is cosine over sine, right? So derivative of this, we can apply the quotient rule. And what is it now? So derivative of a quotient will be the derivative of the numerator, right? Times what? What is next? Yes, cosine times sine derivative. Very good. And the denominator square, right? Now here, cosine derivative, what do we have here? Yes, negative sign and multiply with sign here, it will become negative sine square x, right? And here, cosine times sine square, sine derivative. Bless you. Very good. Sine derivative give us cosine, and cosine multiply with cosine give us cosine square. Okay. And remember, sine square plus cosine square give us 1. Okay. So it means that it becomes here, and here there is a negative sign in front of that. Let us factor it out, right? Sine square plus cosine square, which is 1. Okay. And it will be negative 1 over sine square. So you can write it here, negative, but in front of that, there's a negative sign here, right? So therefore it will be, yes, very good. And the last terms, e to the something, then take derivative, it will be general. Very good. The derivative of the power here, negative 2x times e to the negative 2x, right? So now, so we just rewrite the whole things here, okay? And you can leave it 1 over sine square, or it's up to you if you can write, if you want to write it cosecant square. Both are correct. Yes.
I thought the derivative of cotangent was 1 over 2.
Really?
And sine over cosine is tangent and cosine over sine.
But this is cotangent, right? Oh, you mean 1 plus tangent square? Say your question again.
So I thought the derivative of cotangent was 1 over tangent.
1 over tangent. I don't think so because we do it here very slowly here. If you remember the derivative of cotangent, you can write it immediately. If you don't, do it slowly, quotient rule, and that is what we have here, okay? Maybe you need to double check it more. Or another way, from here, if you don't prefer this one, you can write it this way. This is negative, right? And sine square divided by sine square gives us 1 plus cosecant square divided by secant square give us cotangent square. This is another formula for this, but it's up to you. You can put whichever you prefer. But this is how, if you don't remember, you can just apply the quotient rule, okay? You can write it 1 over sine square or cosecant square. And here, derivative of negative 2x give us what is it? Yes, negative 2 and times e to the negative 2x here, right? So this is the solution of this. Do it carefully, slowly, then we're good. We don't have to memorize much, okay? Is it clear? Then, okay, let us continue. This one. Wanna correct them or wanna skip? Should we do it?
Yeah.
Okay, let us do it. So here, let me erase this one first. Okay, now imagine the general. This is something to the power of 3, right? We take the derivative of this. Which will be, what is it? The power of this times this one, which means very good. And multiplied with perfect. The derivative of the inside. Okay? So let us write it another way. This is u cubed, right? We take the derivative of u cubed, it gives us 3u squared times u prime. And u in this case is 1 minus cosine square of 3x. Substitute this. We have this. Is it clear? Okay? Is it clear or not? Okay, then we continue, right? Again, these two guys are easy. We just rewrite it. This guy is a derivative of a difference, right? Derivative of these two, which will be the difference of the derivative. And derivative of one give us 0, so we don't need to care about this. But then derivative of negative cosine square, right? Again, we can apply this formula again. So derivative of this, the negative sign, we just write it here. Then cosine square, derivative, right? It will be, yes, and 2 times cosine, very good. And and the derivative of cosine of 3x, right? Because in this case, this is derivative of v squared, which will be the same formula, 2 times v prime. And v in this case is cosine 3x, okay? Then, okay, write it here. Very good. And one more time, we need to compute the derivative of cosine 3x squared, 3x, which give us cosine 3x, because here, v squared. Now just look at this. I think it's better to write it down here. Look at this. We need to compute the derivative of cosine square 3x, right? And it will be 2 times cosine of 3x to the 2 minus 1. Do you agree? Then the derivative of cosine 3x. Now, what is the derivative of cosine 3x here? Very good. The derivative of cosine will be negative sign. We do it this way. And then multiply with this guy derivative, right? Or like Andre said, that -3 of sine 3x is fast, but this is how we do it slowly. So we write it here. The number 3, let's see, 1 minus cosine square 3x, then square, we just rewrite it. Number -2 times cosine of 3x times this derivative give us negative sine 3x multiply with the derivative of 3x, which give us 3 here, right? That's it. You don't have to simplify it. If you want, then 3 times 2, -2 times the -1 right here and times 3. Okay.
The original equation, u cubed equals 3b squared times 1. You see that in the number 10.
I write it in terms of u so that you know which one is u to determine and use the chain rule. You understand it. Just understand it. What is u? Ask yourself. What is u in some specific situation? Then apply each formula for each one. We do it first. The first times our u here is derivative of u cubed, and u in this case is 1 minus cosine square, right? Then it gives us this term, and apply the derivative to this. In this case, our u is cosine of 3x. So it depends on the situation. You ask yourself which one is the u that we need to do. Okay, slowly, then you get the result. Okay, so is it clear? Okay, now let us continue. Now, remember the next question is a quotient rule, right? We explained it yesterday. Okay, this is the product of two functions, f and g. The product rule, I'm sorry. Then it will be f prime times g plus f g prime. And again, ask yourself, what is f and what is g in this case, right? Or you can memorize this formula in different notation. U times v prime, which is u prime times v plus u times v prime. It's just a name, okay? Just a name. Then you need to determine which is which. Okay? Then let us take the derivative of these two. So it is clear that we can apply this formula here, which is 5 to the x primes times this one, plus 5 to the x times the derivative of the second guy. And the second guy here, we can rewrite it in terms of this. It make our life easier. Okay. Are we good? Then ask ourselves again, do it slowly. 5 to the something, take derivative, which give us, what is it? Five to the x natural log of 5. Okay, just the formula. Apply it here. And then this one, just rewrite it. And then the second terms here, 5 to the x. Again, this, we can apply the previous formula, u to the n, right? It will be n times u to the n minus 1 times u prime. And in our case here, u is x cubed plus 5, okay? Then just write it. 1 over 3, x cubed plus 5, 1 over 3 minus 1 times x cubed plus 5 derivative. Okay. Then for this guy, it is so easy. We just rewrite it up to this point here, 1/3. And this one, 1/3 minus 1 will be, yes, negative 2/3. And the negative sign, which means we can bring it down to the denominator, which will be the cube root of x cubed plus 1 square. Okay? And the last terms, x cubed plus 1, and take derivative, which give us, very good. Then we can simplify it, but we are not required to do it here, okay? So we can stop here. Sorry? You can simplify it, it is even better, but you want to save time, right? You don't have to, so it's up to you. And again, should we do it with this one? Or move on to another one? Do this one, okay. Very good. Now we take derivative of this guy. This is the derivative of a sum, right? It will be the sum of the derivative. Remember, derivative of sine inverse of something, let us call it u, where u is 2x to the 4th plus 5 in this case, okay? And it will be the derivative d over du of sine inverse of u, the chain rule, multiply with du over dx, right? The chain rule. And remember, d over dx of sine inverse x, what is it? Very good. We have a formula for this one, right? I don't know if it is a correct one. Can you double check it? I think so. Yeah. Derivative of sine inverse will be 1 over square root of 1 plus minus, right? Sorry. 1 minus x squared. This is the variable x, but in our case, it is the variable u, okay? If it is a variable u, it means that this one will be 1 over square root of 1 minus u squared, which is 2x to the 4th minus 5, and then square. That is the first derivative here, okay? Multiply with u prime, which is very good. And the second derivative, remember the formula that natural log of u derivative, it will be u prime over u, okay? And u in our case is tangent of x. It means that it is tangent of x derivative over tan of x. Then do it slowly. You get the result. Okay. Should we do the quiz now? So you have 20 minutes to finish it. Okay. It's two simple problems. So, and for the people on Zoom, the password is good luck Q3. Okay. Sorry.